Mr. Monahan here. This is lesson 9.6b in Expo. Our objective is to continue to look at solving quadratics using the quadratic formula, day 2 of using the quadratic formula. Yesterday we learned what it was. Today we'll just make sure that we understand how the problem is supposed to be set up first before starting, and we will look at word problems and how a word problem might look. So that'll be toward the end of the video. First, graphing y equals ax squared plus bx plus c. Yesterday's video looked at one that was just a binomial. Now we're looking at graphing those trinomials. When you do that, just like with quadratic formula here, you want to understand what a, b, and c are, because you need to first find the axis of symmetry, which is negative b over 2a. And that is equal to negative 6 over 2 times 3, so we have negative 6 over 6, so 1, or x equals 1, is the axis of symmetry of this graph. What that means, sorry, negative 1. So what that means is at negative 1, we have our symmetry that's a vertical line through negative 1. We then also know that the vertex is at negative 1 comma whatever comes out when we plug in negative 1. So we would go, and you could go to the calculator for this if you wanted, but 3 times negative 1 squared plus 6 times negative 1 minus 4, that would give you a positive 3 minus 6 minus 4. So it looks like here we should have negative 7. Okay. So what that means is at negative 1, down here at negative 7, I have my vertex. Then the easiest point to get next is the y-intercept. It's just 0 comma c, which in this situation is 0 comma negative 4. If you plug in 0, the 3x squared and the 6x cancel out. So 0, negative 4, and then I can reflect that blue point over the dashed line to find that at negative 2, I would also be at negative 4. And then some other point, I like to use 1 because it plugs in really nicely. 3 times 1 squared plus 6 times 1 minus 4. That's just 3 plus 6 minus 4, which is 9 minus 4. So at 1, we're at 5. So back down to the graph. At 1, we're up at 5. We have a skinny graph, but that makes sense because we had a 3 out front. This dot is 2 away from the dashed line, so I need a dot 2 to the left of the dashed line. And there's my parabola. The domain is all real numbers. The range is y greater than, since this is opening up, greater than the smallest number y ever got to, which was negative 7. All right, let's move on to today's stuff. Just as a reminder, when using the quadratic formula, it must be set equal to 0, just like when we factored, just like we said yesterday. This one is already set up the way that you want it because we do have one side equal to 0. That's exactly what we want. So first thing we want to do is identify A, B, and C. After we do that, we can plug into our formula. Here it is as a reminder again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we plug in, we have x is equal to negative b. That's negative 3. Got to be careful with that. Plus or minus the square root of negative 3 parentheses squared. Minus 4 times a is 1, c is negative 10. All of this is over 2 times 1, 2 times a. There's a lot here in this problem that can mess you up with negatives. This right here is tricky with negatives. This right here is tricky with negatives. And these two make something tricky with negatives. So you have to be very careful and look for double negatives, or look for understanding what a negative times a negative would be. So negative 3 is just positive 3. So we have 3 plus or minus the square root. Make sure that if you ever go to the calculator early, you use parentheses everywhere that I showed. -3 parentheses squared is +9. Then we have -4 times 1, which is -4, times -10. -4 times -10, these would make a positive number. A negative times a negative is positive. So overall, I should have a positive number here. All right? 4 times 10, or -4 times -10 is 40, and then we also have a 1 in there, but anything times 1 is itself. On the bottom, we get 2 times 1, which is 2. All right, so then we have positive 3 now, plus or minus the square root of 49, and that's all over 2. So this one's going to work out nicely. We got this perfect square right here of 49. What that means is this is probably one I could have factored at the beginning, but that is okay. We're going to keep going this way. We have 3 plus or minus 7 over 2, the square root of 49, which means I have 2 answers. I can have an answer at using the plus sign, 3 plus 7 over 2, or I could have an answer at x equals 3 minus 7 over 2. So I have 2 answers that come from this. One of them is 10 over 2, which is 5. One of them is -4 over 2, which is -2. So I have x equals, I want to write x equals here, I'm sorry. X equals 5. One answer is x equals -2, which again we could have factored to get originally. Okay. Before you figure out what A, B, and C are for the second one, make sure that you have the equation set equal to 0. This one does not. I need to subtract a 2x from both sides. You also want to pay attention to what order this should go in. X squared, or the thing that is squared, should be first. The next thing we want is the x to the 1. We want this to be in standard form. Otherwise, we might mix up what B and C are. So subtract 2x, that should be the next thing, and then the -8. That's equal to 0. So we want to make sure we still have this in standard form. Okay? Standard form means biggest exponent to smallest exponent. Okay? All right, now we can look at A, B, and C. So A is 1, B is -2, C is -8. And that's how we're going to set this one up. So x is equal to -b, that's -2. Plus or minus the square root of b squared, that would be -2 squared minus 4 times a is 1 times c is -8. This time everything is over 2 times 1, so just going to be 2 again. Okay, this is equal to 2 plus or minus the square root of -2 squared is +4. Again, I have a -4 and a -8 that are going to make a positive number. So, and then my last number 1 is also positive, so this is going to be another time where I'm adding. And then this time I'm adding 32. All of this is over 2. Okay. Then I have that x is equal to 2 plus or minus the square root of 36 over 2. And I know that the square root of 36 is 6. So I have 2 possibilities for answers here. One, when I use the plus sign. So one answer is x equals 4. And one answer, when I use the minus sign, x equals 2 minus 6 over 2, which is -4 over 2. So one answer is -2. X equals -2. Again, we're getting nice answers, not decimals for some of these, because we could have factored them, and that probably would have been the best way to do it. Okay, 2 numbers that multiply to 8 that add to -2, and then solve by factoring. Okay. All right, we're going to subtract 21 from both sides for this one. we want it to be in standard form, so we want the 21 to be the last thing, since we don't have, since we want it in standard form. We already have the x squared and the 4x in the right spot. So then A is 1, B is negative 4, C is negative 21. Okay? So this one's going to work out similarly, where we're going to get a nicer answer, because you could look and see that this factors. So the factoring version of this really quickly would be x plus x minus something. Two numbers that multiply to 21 that are at 4 apart would be 7 and 3. Negative 7, positive 3. So we would have that x plus 3 equals 0, or x minus 7 equals 0. So one answer of negative 3, one answer of 7. And I'm going to show you with quadratic formula, we would get the same exact thing. But factoring is faster, so if you can see a way to factor, it's good to try to do that instead. Okay, that's the factoring way. Here's the quadratic way. X is equal to negative b, that's negative 4, plus or minus the square root of negative 4 squared, in parentheses, minus 4 times a times c is negative 21. All of that is over 2 times a, which is 1. So x is equal to positive 4 plus or minus the square root of positive 16. Once again, we get a negative 4 and a negative 21. We have two negatives, which means we have a positive. Okay, an even amount of negative numbers right there will give you a positive number. So this is just going to be 84 all over 2. So we have that x is equal to 4 plus or minus the square root of 100 over 2. Again, every time, if you get a perfect square right here, it makes the math nice, but it also tells you we could have factored this like I already showed you that we did. Okay? So we have 4 plus or minus 10 over 2. Well, that means that x could equal 4 plus 10 over 2. And we have an answer at x equals 4 minus 10 over 2. This one gives you 14 over 2, which is 7. This one gives you negative 6 over 2, which is negative 3. And you can see that those answers match the factoring ones that I already gave. So it's a good idea to check if you can factor, because that's always going to be a little bit faster, always a little bit more convenient for you to try it that way first. Okay, so that's how you can use quadratic formula if it's not set equal to 0 first. Just get one side equal to 0 before you start. All right, now we'll talk about these. These are not going to factor well, because if you read ahead or skim a little bit, you'll see this equation that we're going to need to use. Well, that's not going to factor very nicely. Numbers that multiply to 2, that add to 0.84, but also needing a negative 0.04 out front, looking at those factors. We're not going to be able to factor this. We're not going to be able to solve this by square root since it's a trinomial. So this is going to have to be a graphing one or quadratic formula. Let's read it. In the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation that's given. Negative 0.04x squared plus 0.84x plus 2. Where x is the horizontal distance in meters from the athlete and y is the height. So what's happening here is we have somebody throwing the shot put ball, okay? And it's going to go up a little bit, and then it's going to come back down to earth. Okay? X is how far it went. Y is how high the ball is above the ground. Okay? What we're looking for, how far from the athlete will the ball land? Well, they want to know how far this was, what this distance was. This is the question mark. How far did it go? Okay? Well, think about this. The ball will land when y is equal to 0. 0 feet high. We want to know when will the ball be 0 feet off the ground. So what that means is we want to set this equation, we want to put 0 in right here. We want to put 0 in for y, and we want to solve for what x gives us a height of 0. So let's do that. I'm just going to copy down the equation but set it equal to 0. And once we have it set equal to 0, we can identify what A is, what B is, and what C is, and we can use that to try to solve. We're going to use quadratic formula to figure this out. So that would be first step, x is equal to negative b, that would be negative 0.84 plus or minus the square root of 0.84 squared minus 4 times a, which is negative 0.04, times c, which is 2. All of that is over 2 times a, which is 2 times negative 0.04. As you can tell, we're going to need the calculator to simplify some of this stuff, so I'm going to pull that up in just a second. We have negative 0.84 out front, plus or minus the square root, and let's simplify some of this stuff. Okay, and I can show you too, you can do some of this calculator stuff in one step. You just got to be a little bit careful. But we can get the 0.84 squared. Since it's positive, I'm fine, but I really should have typed it in like this to be safer. And that's how I've been telling you to do it, so I should probably be a better example there. But it was 0.7056. Okay, the next part I'm typing in is negative 4 times negative 0.04 times 2. So let's get that back up. So we have parentheses negative 4 times negative 0.04 times 2. Notice that that's a positive number there, a positive 32.32. So I have plus 0.32. All of this is over 2 times negative 0.04, which is negative 0.08. Okay. So one more simplified step before we go to the calculator on the square root. So we have negative point. I'm going to write this down here since I want to be able to see it when I use the calculator. But we have negative 0.84 plus or minus the square root. If you add those together, you get 1.0256. Okay, adding those together, you get 1.0256. All of this is still over negative 0.08. Next thing I might do is the square root of 1.0256 and get 1.01. So then from there, I have negative 0.84 plus or minus 1.01 all over negative 0.08. Now I'm ready to get my answers. One of these answers is not going to make sense because it's going to be negative. The other one will be a good answer. So again, I'm going to write down here for when I pull up the calculator, x is equal to negative 0.84 plus 1.01 over negative 0.08. Here's what's going to happen here. You're going to get like a 0.17 over negative 0.08. This answer is going to be negative since it's a positive over a negative. So since this answer will be negative, we're going to get rid of it because we can't throw the ball a negative distance. The ball is going to definitely go forward. So negative 0.84 minus 1.01 over negative 0.08 is the one that we're going to keep because here we get like negative 1.85. Sorry, I said 5, I wrote 4. And that's over negative 0.08. That answer is going to be, sorry if you can't read this, I'm just going to do that over again, negative 1.85 over negative 0.08. Okay, that's going to be a negative over a negative, which will be positive, and that's going to be the answer that we do want, which we will punch in right now. So you can type the negatives in if you want. We know that they're going to cancel. So you could leave them out if you wanted for this one. But 23.125. So that is how far in meters that the shot put ball would have gone. Okay? So a lot of work because it was quadratic formula. All right, but we found that this distance is 23.125. Okay? We had to use quadratic formula because look at how messy the original equation was. That was not something that we were going to factor very easily. All right, we have a couple more of the word problems. I think I'm just going to go through it one more time. So let's look at skipping one. We're going to skip the one with the baseball. We're going to go straight to the one with a soccer ball. All right, so Daniel kicks a soccer ball up into the air with an initial upward velocity. Yeah, perfect. All right, so as you look at this, there's one thing we got to remind you about. That would be that piece of understanding the height function with in seconds with gravity. So the height is going to be equal to this negative 16t squared. That's always part of that equation that we've looked at, plus the initial velocity, which is 64t this time, and plus the height. It was 2 feet above the ground when we started. So with a situation like this, the first question, or the only question, is when will the ball be on the ground? I might have skipped a little bit there, but what that means is solving for when h equals 0. So instead of the h right here, I've just replaced it with a 0. And now I want to know when will the ball be on the ground. So I'm already set up to solve this using quadratic formula. Because a is negative 16, b is positive 64, c is positive 2. I'm ready to solve this. I could try to look at factoring it, but it'll be complicated with the negative a term. So x equal to negative b, that's negative 64. Plus or minus the square root of b squared, which is 64 squared, minus 4 times a, which is negative 16, times 2, which is c. All of this is over 2 times a, which is negative 32. Let's simplify this up a little bit. We have negative 64 plus or minus the square root. So in here, we're going to get bigger numbers, and that's okay. Just use a calculator and be careful. The 64 squared part gets you 4,096. I have two negative numbers that will multiply to be something positive. So I need a plus sign here. 4 times 16 should be 60. 4 times 2 should be 128. That's a positive. Over 2 times negative 32, which is negative 64. That's equal to negative 64 plus or minus the square root of combining those, 4096 plus 128. That gets you 4,224. All of that is over negative 64. Okay? So if you do the square root of 420 or 4,224, you end up with a decimal, and that's okay. Remember, word problems, quadratic formula problems, decimals don't mean you did anything wrong. If you plug that in, you get basically almost 65, 64.99. Okay? If you plug that in. All of that is over negative 64. So what's going to happen here is, again, if I use the plus sign, negative 64 plus 64.99 over negative 64, what I get there is positive 0.99 over negative 64. We can type that in and get like negative 0.015. But this answer is negative, and this would be in feet. Or sorry, this would be in seconds. This is how many seconds until the ball hits the ground. But that doesn't make any sense. The ball is going to hit the ground negative 0.015 seconds before it hits the ground. Oops. So, or we could use the negative sign, negative 64 minus 64.99. That's over negative 64. Now we're going to get a negative over a negative. So this would be negative 128.99 over negative 64. So let's plug that in. And you get 2.01 or 2.0, about 2.02 seconds after the ball is thrown, or the ball is kicked. So 2.02 seconds after it's kicked, it would be hitting the ground. All right, that's it for today. Quadratic formula. Feel free to ask me whatever questions you still have after viewing. Thanks for watching.